Let's drop!
Alright, what's going on, guys? Mr. Flores here, and as you can see, this video deals with solving a system of equations using elimination. Now, we already solved system of equations graphically. We already solved them using substitution. So, if we look here, we have three systems. Y equals 3x plus 6. Y equals 4x plus 7. Since both of these equations are in y equals mx plus b form, I would solve these graphically because there's no manipulation. You just graph the two lines, find their intersection, you're done. Here we have y equals 5x plus 3, 3x plus 2y equals 10. One equation's in slope-intercept form, the other equation's in standard form. I would solve these using substitution because all you have to do is substitute this y into this equation, this whole y into this equation, solve for x, bada bing, bada boom, you're done. But now we're given two equations, 2x minus y equals 3, 3x plus y equals 2. And what we have to do is solve this using elimination. Well, we don't have to solve it using elimination. It's just the easiest method since we don't have to manipulate it algebraically at all. So if we look here, we have 2x minus y equals 3, 3x plus y equals 2. The whole idea of solving a system of equations using elimination is you want to eliminate or cancel out one of the variables by either adding your equations or subtracting them. The first thing you have to look at is the coefficients of your variables. The coefficient of x's is 2 and 3. Those aren't the same number, so it doesn't work. This equation, or this problem, has -1 and a +1 as the y coefficients. Since both coefficients are the same number, that's good, because we can eliminate the y's by either addition or subtraction. Now we have to ask ourselves, a minus y and a plus y. What do we have to do with -1 and +1 to make it go to 0? And if you know anything about arithmetic, if you add the negative version of a number and the positive version of a number, it goes to 0. So just add everything together, though. So 2x plus 3x is 5x. -y plus y is 0, it cancels. 3 plus 2 is 5. So essentially all we did was eliminated our y variable. So now we have 5x equals 5, divided by 5, and x is equal to 1. Okay. Now, once you find your first variable, the same idea or same concept of using substitution comes back into play because we can take this 1, substitute it into either of our equations. I'm going to substitute it into the first one just because it was on the bottom, it was actually closer to write the arrow. So when I rewrite the equation, it's going to become 3 times 1 plus y equals 2. 3 plus y equals 2. We're going to subtract 3, y equals -1. So we know what our x is, we know what our y is. Again, when you write your answer, write it as a coordinate pair, x comma y, and we're good. So our solution to this system of equations is 1 comma -1. Alright? And that's elimination in a nutshell. It does get easier, however, because if you look here, this system has -2x plus y equals -1, and x plus 2y equals 3. Like I said, the first thing you need to do is check out the coefficients of your variables. The x's have a -2 and a +1. The y's have a +1 and a +2. Now, we can't add or subtract anything yet because none of our variables are going to cancel because the coefficients aren't the same numbers. But as we know, algebraically, we can manipulate equations to work in our favor. So really what we want to do is we need this 1x to become a 2x, or this 1y to become a 2y. It doesn't matter which way you do it, as long as you do everything mathematically correct. What I'm going to do is multiply this second equation by a factor of 2, or increase it by a factor of 2. Because if we multiply this 1 by a 2, it's going to become 2x. Both of these will be 2x, and we'll be good to go. So when I multiply the second equation, it becomes 2x plus 4y equals 6. Remember, we must distribute that 2 to every single term in the equation, just so we don't change it mathematically. And I'm going to write the first equation just above it. Alright, so now once we multiply everything by a factor of 2, we get negative 2x plus y equals negative 1, and our new version of the equation is 2x plus 4y equals 6. Both of our x's are 2's. This one's a negative, this is a positive. So in order to cancel them out or make it go to 0, we must add them together. So negative x plus a 2x goes to 0. Y plus a 4y goes to 5y equals negative 1 plus 6 is a 5. Again, divide both sides by 5. And you get y is equal to 1. All right. Now, we know y is 1. A lot of people ask, when you substitute your y or whatever variable back into the equations to get your missing variable, it doesn't matter if you substitute it into either of the initial equations or the one you created, because in reality they all work. What I'm going to do is substitute the y into this equation just because it's the easiest. There's a lot less math to do. So if we rewrite that equation, it comes out to 2x plus 1 equals negative 1. Oh, that's a negative 2. All right. So what we're going to do is subtract 1, subtract 1. We get negative 2x equals negative 2. Divide by negative 2. And x equals a negative 1. So again, we must write our answer as a coordinate pair, and you get negative 1, comma 1. And that's your solution. All right, I'm going to do, first off, let me kind of say this. This first problem we did is of the easy type, because we don't have to multiply either equation by any factor. Okay, we can just straight up add or subtract, and it eliminates. This is a medium problem because we had to multiply one of the equations by a number to cancel something out. This is another example of a medium, and I'll explain because we have 6x minus 8y equals 16, 3x minus 4y equals 8. Neither of the coefficients of x's or y's are the same number, so we can't eliminate anything yet. So we must multiply one of the equations by a number. And if you're thinking or using your brain a little bit, you realize that we can multiply this top equation by 1/2, or we can multiply the second equation by 2. I'm going to go ahead and just multiply the second equation by 2 because you guys don't like fractions. And when that happens, our x's will both have a coefficient of 6. So I'm going to rewrite the top equation here. 6x minus 8y equals 16. Then the new equation, 2 times 3 is 6x. 2 times negative 4 is negative 8y. 2 times 8 is 16. All right. If you guys remember from when we first learned how to solve these graphically, you'll already know right off the bat what the answer is going to be. But just for those who don't, let's keep going. We have a 6x and a positive 6x. In order to eliminate those or make it go to 0, you must subtract them since they're both positive. So 6x minus 6x is 0. Negative 8 minus a negative 8. When you subtract negative, it becomes addition, so that's 0. 16 minus 16 is not 16. It is 0. So therefore, 0 equals 0. That's a true statement. So our answer is going to be infinite solutions. If you remember back to the video on graphing, right off the bat, you saw that both our equations were exactly the same. And if you have two equations that are the same, it's infinite solutions because nothing can change. All right? And again, this was a median problem. So this is your answer, infinite solutions. But again, this is a median problem because all we do is multiply by a factor of 2. Now we get a hard one. Because we have 4x minus 3y equals 25. Then we have negative 3x. Negative 3x plus 8y equals 10. Oh, what happened here? There we go. I don't know what that was. So if you look here, neither the x's match, neither of the y's match. But we can't just multiply either of these equations by a factor to make a 4 become a 3 be a 4, a 3 be an 8, or an 8 be a 3. So really what we have to do is, now we have to multiply both equations by something. So if you look at the problems here, you want to find out what's the least common factor, or least common multiple between 4 and 3, or 3 and 8. I'm going to go with the 4 and 3 because it's easier, and that number is going to be a 12. So in order for a 4 to be a 12, we must multiply by 3. In order for a 3 to be a 12, we must multiply by 4. And again, you're going to have to distribute to every single term. The reason why this is a hard problem is because you're multiplying both equations by a number. So this is going to become 12x minus 9y equals 75. Negative 12x plus 20, or no, not 24, 32y is equal to 40. Alright, and now again, the x's are going to cancel since they're both 12. This is a positive 12 and a negative 12, so you must add them together. So 12 plus negative 12 cancels. Negative 9 plus 32 gives us 23y. 75 plus 40 gives us 115. Alright, divide both sides by 23. Y is equal to, what's that? That's 5. It's just y is equal to 5. I don't know why it took so long for me to figure it out. Alright, so now we know that y is 5. Again, what you must do is take the y, substitute it into either equation. A 9 is smaller than 32, so I'm going to use that one. So when you write your equation down here, it's going to become negative 9 times 5 equals 75. I forgot the 12x. Alright, so it's going to become 12x minus 45 equals 75. Add 45. Add 45. Those cancel, and you get 12x equals 120. Alright, because 70 plus 40 is 110. 5 plus 5 is 10. So 12x equals 120. Divide by 12. Divide by 12. X is equal to 10. We knew that y was equal to 5. So your answer is 10, 5. And that's your final answer. Again, guys, this was a hard version of the problem because you had to multiply both the equations by a factor. If you have questions, you can Google it, email me, check out some of the things on the website. Hope you learn.